Covalent bonding. Again, covalent bonding would be the sharing of electrons. So we're going to talk about Lewis structures. We've already done one of an ionic compound with sodium chloride. Well, the first thing we did was we actually did the Lewis symbol for NaCl. And that happens to be right here. So this is the Lewis symbol for NaCl. That's what this is right here. So a Lewis structure is a representation of molecular compounds which depict neighboring atoms as sharing some or all of their valence electrons in order to attain octets or duets. Octet sounds like 8. So an octet is that main group elements want 8 valence electrons to fill their valence shell, which makes them isoelectronic with a noble gas. Duet is an atoms that want 2 electrons in their valence shell. Of course, hydrogen, helium too, but hydrogen wants 2. Little note, H, of course, He, Li, Be, and B can have less than 8 electrons. So they don't always need to have an octet. In fact, hydrogen would be weird having an octet because there's only 1 proton. And the ones we have to worry about, hydrogen and boron, are the 2 we'll mainly worry about. Helium, not at all. Be also will only have 2. Boron can have 6. So boron's special. So let's talk about some key points. One, the first point is that electrons are shared in pairs between atoms, and that's a bond. We do 2 electron bonds. All our bonds are 2 electron bonds. And 2, a sufficient number of pairs of electrons are shared so that the number of electrons in the valence shell is equal to that of the next noble gas. And it kind of goes back to the point of being isoelectronic with the noble gas. Right, that's why we get octets. Now, let's talk about some guidelines. All right, guidelines for drawing Lewis structures. Now, I'm going to start with step 0. And why step 0? This is just how I recommend. Because Lewis structures are not, they're trial and error. They're not, we go in. We're going to do a lot of these by inspection. We're not going to go in unless you know it already, which you may. Chances are we're going to have to do some erasing. Not because you did anything wrong, not because we made mistakes. It's just trial and error. It's by inspection. So I am going to recommend pencil, or nowadays electronic tablets, something like that. Number 1, step 1, is to calculate the total number of valence electrons. Not total electrons, only valence electrons for the molecule. Step 2, we write the correct skeletal structure for the molecule. That means we're going to put the atoms, we're going to lay out the atoms and arrange them appropriately. Some of you have moved, maybe some more than others. And you go to places where your furniture goes, and there's only one way to put the furniture in. And sometimes there's more than one way to put the furniture in. And this happens with atoms. Sometimes there's only one way to build them. Sometimes there's multiple ways to do it. So we kind of got to know the correct structure, how it's laid out. And we'll get there. We'll learn the central atoms, usually written first. It's less electron negative. We'll learn how to tell if there's more than one central atom. We'll learn this stuff. So don't take a deep breath, but we'll learn it. But it is important to write the atoms correctly. It's like hydrogen and fluorine will not be in the middle. We'll cover that. That's good to know. Step 3, we have to bond the atoms. Right? Those are 2 electron bonds. We're going to bond them. Step 4, we distribute the electrons among the atoms. Giving octets to as many atoms as possible. Five, there's 2 points. If any atom lacks an octet, at this point all the duets should be fine, right? So they should be good. So now if any atom lacks an octet, what we do is we form double or triple bonds as necessary. extra electrons, let's say we don't have, everybody has enough electrons, and everybody has an octet, then extra electrons go on the central atom as lone pair or pairs. Depends how many you have. So those are the guidelines to draw these Lewis structures. And so that's what we're going to do next.